Okay, good evening. This is Professor David J. De Los Reyes. Okay, it's September 15, 2023. The time is 11:38 p.m. Okay, my topic for this session will be long video format discussion on college algebra, and this will now be lesson number 63. We are almost done with the college algebra long form discussion. Okay, let's proceed. The subject matter for tonight will be a long video format discussion on college algebra. So this is college algebra, and this will now be lesson number 63. And the title of the topic for tonight will be evaluating composite function, or meaning evaluation of composite functions. Okay? Composite functions, it's just like this is synonymous to the so-called composite. It should be, the proper word will be combined. Combined. Evaluation of, or evaluation on how to combine functions. Composite. Okay. Okay, let's try to bring out the definition of the so-called composition of function, meaning on how to combine functions under algebra. This is just what you call this, combining two algebraic functions in algebra. So there is no hard thing about it. This is just combining two algebraic functions in algebra. Okay, composition of function. We are given two functions. The first function is f of x. The second function is g of x. First function, second function. The only problem here is how to combine these two functions here. There's no hard thing about it, right? And the problem is asking the composite or combined function of x. If we are given these two functions here, if we are to combine it, we term to as the combination is actually a composition, right? So composition is just like a combination. So if we try to bring out the setup on how to combine functions under the study of college algebra, this is just an invention of mathematicians, you know. By definition, okay, function f, okay, we got a symbol at the middle. That's not a dot. It should be a little circle like that. And under the study of college algebra, that is the meaning of that is actually the symbol for composite, or combining the two terms. Okay. So if we try to read this one, if we try to combine function of x and g of x, okay, the right hand side will be function of open bracket g of x close bracket. Okay, that's the proper way how to simplify this one. If we try to combine function of x and g of x, okay, it should be function of open bracket g of x close bracket. That's it. No hard thing about it. So for any problem under the so-called evaluation of composite functions, this is the equation that is to be needed. That is, if we try to combine function of x and g of x, this symbol here, this is not a dot, it's a small letter circle. It's a bigger circle, it's a bigger thing than a dot, because a dot is just something like this, right? But this one, it got a hole at the middle. And that symbol is actually a symbol for composite, meaning we are combining function of x and g of x with this symbol here. So, okay, I will try to repeat it. To combine function of x and g of x, I will read this. F, this is a symbol for combining g of x. This should be equal to, the right hand side should be small letter f, the first function, okay, open bracket, g of x close bracket. And here, we are not multiplying. Not. Okay? this symbol here, it is not a multiplication. You will see later on why I said that the operation on the right hand side is not multiplication. It is just a designation. That is, if we try to combine function of x and g of x, it should be function f, okay, open bracket, g of x, close bracket. Okay, it's not multiplication. And this is read composite or combined function of x. Okay, because the two given functions are actually given as a function of x. For both the first function and the second function, am I still on camera? They are expressed as a function of x. Okay, so this is of x. Okay, let's try to bring out an example by using the definition or how to evaluate a composite function. Composite function meaning two functions which are expressed as a function of x. The problem is just asking if we try to combine them, what will be the combination? That's the so-called requirement of the problem. We are just asked to combine them. That's why this is evaluation of composite function or combined function. Okay, let's try to bring out example number 1. For example number 1, we are given f of x we are given a quadratic equation. A 2x squared plus 5x minus 9. And the second function is g of x equal to 3x minus 17. Obviously, the first function is a quadratic equation. So this should be a parabola. The second equation is actually a linear equation. So this should actually be a straight line. The problem is asking if we try to combine this parabola and this straight line here, what will be the outcome? What type of equation that will come out? That's why the term here is combined. Right? If we try to combine this one, okay, what will be the required equation? Okay, let's try to bring out the solution. So the problem is asking f as a function of x, we try to combine them with the equation g of x, what will be equal to? This symbol here is the symbol for combine. Okay, it's a small circle. Okay, so I will repeat it. Find function of x, we try to combine it with g of x, what will be the value? Well, the problem is just asking if we try to combine equation number 1 and number 2, what will be the result? That's it. No big deal about it. Right? If we try to bring out the solution, okay, by definition, f of x, we combine it with g of x, okay? From the definition, we'll follow this. It will be f, open bracket, g of x. Right? And if we try to simplify this one now, the proper way on how to simplify this one will be this. What is g of x? Are we given g of x? We are given g of x, right? Right? So this will now be equal to, it will be f, g of x is actually 3x minus 17. Right? For g of x, we will substitute its value to be 3x minus 17. Then try to simplify this one. What will be the value of f of x if the value of x is 3x minus 17? That's the meaning of this. So, like what I told you a while ago, we are not multiplying it, right? Okay? We just designate this one with a certain value, and this is under this function here. So, meaning to say, a function of the quantity 3x minus 17, what will be the value? Okay? What is function of x? It is 2x squared plus 5x minus 9. So, by placing the value x, we replace x here by the value 3x minus 17 because g of x is actually 3x minus 17. So, by following f of x, it will be 2. The new value of x, we are combining it already, right? The new value of x which comes from g of x is actually 3x minus 17 quantity square. We are finding this. Plus 5. The new value of x, okay, will be 3x minus 17 minus 9. As simple as that one, right? So simplifying this one, this is 2. We are expanding a binomial. It will be the square of the first term. We have just discussed binomial theorem, so this falls under n is equal to 2, right? Right? So the first term is just the square of the first term. The last term is just the square of negative 17. That will be 289. Okay. There is a middle term. The middle term is the product of 3 times 17 times 2, and that will be negative 102, but it should be multiplied by x. So this is square of the first term, the square of the second term. The middle term is the product 3x times 17 times 2, that will be negative 102x, close quantity. 5 times 3x will be 15x, okay? 5 times negative 17 will be negative 85 minus 9. Simplifying, right? The first one is a quadratic second power, right? 102, right? Times 2, that will be negative 2 over as a coefficient multiplied by x. Of course, 2 times 9 is 18, right? And 2 times 289, that will be 578 plus 15x minus 94. Combining similar terms and simplifying it, it will be 18x squared minus 189x plus 484, because 578 minus 94 is actually 484, and that will be the answer. Okay? So if you try to notice it, the combination of a parabola and a straight line, what will come out is still a parabola, a second degree equation. That's the meaning of this. That's why evaluation or combining functions, okay? We are given a first function, we are given a second function, we try to combine it, what will be the result? Okay? The combination of function of x and g of x, this is a symbol, right? Standard for college algebra, right? It will be 18x squared as final answer minus 189x plus 44. As simple as that one. So composite function is just what we call this, combining two algebraic equations. Okay? Last example for tonight. Oh, this is an easy one, guys. Example, we are given function of x is 2x squared plus 5x minus 9. The second function, instead of g, it's h, letter h of x. It will be the square root of x plus 4. The problem is asking, if we try to combine these two equations here, but the problem here, we are given an exact value. If we try to combine these two equations with the value of x equal to 4, okay, what will be the value? So the problem is asking for an exact answer, a pure constant answer. Okay, let's try to bring out the solution. By definition, okay, if we try to combine function of f, okay, with the subset, we start with x. We start with this. We try to combine f and h, okay, the original variable will be x. Like what I said from the definition, it should be function of open bracket h of x, right? But this one now, the value x, there was a specified value 4, so this is not 4, right? Okay, so this will be 4. Okay, so this one here emanates from that definition. The only problem is that the value of x is specified. So, okay, so function of function of x when the value is 4 and the function of h when the value is 4, what will be the required, what will be the result if we try to combine them? If we try to combine them by using the definition, it will be function of open bracket, function of function of h as with the value 4 of close bracket. Okay? And to simplify, to get the value of this, we can compute for the value of this. We will start with h as a function of x. What is h as a function of x? It is the square root of x plus 4, right? So when x is 4, h with the value 4 now will be the square root. It is actually this. Okay? H as a function of x is the square root of x plus 4. So when x assumes the value 4, h as a function of 4 will now be equal to the square root of x, which is 4 plus 4. Am I still on camera? This is the square root of 8. We could bring out 1, 2, because 8 is actually the product of 4 and 2. If we try to take the square root of 4 is 2, and the square root of this is 2. So h, when the value is equal to 4, is actually the simplified value is 2, the square root of 2. Okay? So in here, we will place the value here to be 2, the square root of 2. Right? But this is under function of x. Right? Okay? Assume for the meantime that this is x. So if we try to simplify this one, what will be the given function of x when x now is with the value 2 the square root of 2? Where we got this value of 2 the square root of 2? From the value h of 4, right? It is this. So function of 2 the square root of 2. The meaning of this, what will be the value of f of x when x assumes the value 2 the square root of 2? And this 2 square root of 2 emanates from this. Right? So by using function of x and substituting the computed value from h as a function of 4, this will be 2. We'll find this 2. This is 2 the square root of 2 squared plus 5 times 2 the square root of 2 minus 9. Okay? Right? So this is 2. The 2 the square root of 2, this is actually square root of 8. And the square of the square root of 8 is just 8. 5 times 2 will be 10, the square root of 2 minus 9. So combining similar terms, 16 minus 9 plus 10 the square root of 2. 16 minus 9 is 7 plus 10 the square root of 2. So the combined value of f function of 4 and h of 4, okay, with the value 4 is actually 7 plus 10 the square root of 2. That's the final answer. As simple as that one. Actually, this problem here is almost similar to this, except that on the second example, instead of just x, we are given the value of x, and that value of x is actually 4. Okay, have you got the solution, guys? Right? This is with the value 4. The meaning of this, what will be h of x, h as a function of x when x assumes the value 4. And we have computed it to be 2 the square root of 2, or just simply the square root of 8. So what will come out here will just be simply function now. Like what I said, we are not multiplying, right? The value of this, the new value of x for function of x will be 2 the square root of 2. Right? So if we try to simplify, this will be the final answer. Okay, that's it, guys. That's the way on how to combine two algebraic functions. Okay? It will be by using this formula here. Okay, I will repeat it for the last time before we go for tonight. The combined value of function of x and g of x should be equal to function of open bracket, function, literal. It's the first function. Okay? G of x. Okay, that's the proper formula on how to combine two algebraic functions under college algebra. You know the significance of this, guys? Our book said that this is used under differential equation. Yeah, we use this under differential equation, or actually differential calculus. This is under the so-called parametric equations. Because under parametric equations, sometimes we are given x as a function of time and y as a function of time, right? So we are given two equations here, and they are related with each other with respect to time. and there could be another third variable S maybe, and we need that relation to be, we must have to bring out this S here. It's just a representation in terms of a function of x and y, right? So to get S as a function of x and y, we are given the first equation, we are given the second equation. So if we try to combine them, placing them under S, we are now given S as a function of x and y. And this is here is termed to as a so-called combined value of x and y. The combined value of the first equation, okay, or first function, plus the second function. Okay, good evening from Los Angeles. This is Professor David J. Los Reyes.